Okay, we are doing a flipped assignment here, and it's on titrations. Okay, so this is the model. So in doing this, the very first thing you have to do is this is basically a stoichiometry problem. And step number one, if the equation is not balanced, you won't be able to solve any of these. So if you look over here, it says balance. We have one H3PO4, which is the acid, 3 bases. It yields 3 waters and 1 sodium phosphate. Now, the next part, B stands for before. So if we look, before we do anything, if you see the B here, this is before. I said, okay, 3 moles. This is saying this is what we're starting with. I've got this in my beaker right here. So I did 3 of these molecules just to try and show that, hey, here's the acid. I've got 3 of those. Then, sorry about that, the next one is my bases. Here, up here it says I've got 6 moles of the base. Here's my base. Here's the key for it. Here's the 1, 2, 3, 4, 5, 6 of a base. And initially, over here, before anything happens, I have none of the products. So now I'm going to mix these together. And let's see how I mix them. Well, first of all, the change, if I look up here, I'm going to use up some of the, we don't know how much, so I'm going to use up some of the acid. I'll use up some of the base. That's takeaway. That's a minus. We'll gain some of the products. So let's just follow the balance equation. So for every 1 acid I need to use, so for every 1 acid, I use 3 of these, right? 3 of my bases. And that means I should get, every time I do that, I get 3 waters. So I can write in 3 waters, and then I get 1 of my Na3PO4. Now look, I can do this again. Again, 1, because of this up here, 1 acid. Every time I use 1 acid, I use 3 bases. 1, 2, 3. I am now out of base. I can draw in my products. Now, I have something left over here. I've got this acid that's left over. There's no base left to react. I can draw that here. Now, when I do that, here's what I end up getting. We do the change. We put it in, and here's what happened. Again, every time I use 1 of these, I do 3 of these, I get 3 waters right there. I use 1 of these, I do the other 3 of these, I get 3 waters, and then every time I do that, I also get 1 of the sodium phosphate, 1 of the sodium phosphate. This couldn't react with anybody, so I just put it right over here. Okay. Now, how do I write that up here? Well, did I use how many moles of this of the H3PO4 did I end up using? And the answer was I used 2 of those. How much of all of this did I use over here? Over here, I used of the base, I used 6. Right? Now, if we follow this along, how many of the waters did I end up gaining? Well, I gained 6 over here, and again, it's a 1-to-1 ratio. How many of the Na3PO4s did I gain? I gained 2 of those. Okay, so let's just add this up. 0 plus 2 is plus 2. 0 plus 6 is plus 6. Okay, 6 minus 6 is 0. 3 minus 2 is 1. So I've got 1 acid left. So at the final, very end, let's see if this matches up. Here's Na2PO4. Okay, it's neutral. I got 2 of those. Here are my 6 waters. Got those. I have no base, and again, I had the 1 acid left, which is right there. Okay, now let's see if we can answer the questions. Limiting. Okay, I have more acid than I have base. The base has all been used up. In this case, the NaOH is the limiting. You look at what you have left over. What's the leftover excess? It's the acid right there. Okay, so I have the acid, right? That's of the reactants. What will the pH be in the beaker? Well, this is neutral. This is neutral. There's my acid. The pH will be less than 7. Okay. Don't worry about this one, but if I had phenolphthalein for the indicator, that one you don't have to answer because some people use that and some people didn't. Is this before, at, or after the equivalence point. Essentially, this means this is what we're trying to show here. This is after it goes neutral, but then we have more acid. And then we figured out what the pH was because we said, look, it's going to end up being acidic because I have leftover acid. This is probably the hardest problem, and it just goes through each one. And I find the easiest way to do it is just to make the models. So again, this is the before. This is what they give us. Okay, this is what we have, but we have to follow the 1 to 3 ratio or whatever they have in the balance. So if I have 2 of these, I can use 6. I have 1 left over, and again, because the NaOH to the H2O is 1-to-1 ratio, if I use 6 here, I gain 6 here. This is a 3-to-1 ratio, so if I use 6 here, okay, I gain 2 here. Okay, so this is which 6 divided by 2 is 3. And the modeling is trying to show it. So see if you can do these, and this is probably the toughest one. Thanks a lot. Have a great day.